Thank you, guys. Can you hear me all right? Because, OK, I will try to speak quite loud. All right, so my name is Łukasz Olszewski. I work in Atos. I'm leading CSER, Threat Intelligence, and EDR there. So this is like my day job, but the other part of my engagement in Atos is related to this small circle that I actually wanted to mention here. It's called, we have a thing called Atos Experts Community, and this is the place where I can also, let's say, pursue things that interest me and that are not necessarily part of my daily routine. So we have also a place for research, for development, and this will be also related to the stuff that I want to talk to you about today. So the topic of my presentation is well, data science and orchestration in service to cybersecurity breach detection and response. So I would like to talk to you about what we have been doing in Atos for the last 1 year, exactly in this area. So how to improve detection and how to improve response, basically and mostly using the things and the data that we already collect for ourselves, for our customers. And hopefully this short talk will inspire you maybe also to look for similar improvements in your environments. It's not related to any specific product, right? So there is a couple of services that we needed to orchestrate together. So yeah, so let's start. I will start with this quote. He said that the CEO of FireEye, he said that at this year at RSA conference, and I realize the risk of saying such a thing at a conference like this one, where we have a lot of red teamers. But the matter of the fact is that I've also I share this view, right? I have a feeling that being a blue teamer myself, I did a bit also. I did work a bit in the area of red teaming, but I do have this impression that we sort of need to be, as blue teamers, we sort of need to be right all the time, right? And the guys who are attacking us, well, not necessarily. Sometimes it's okay if they are right just this one time. So this sort of sets the stage for this presentation and why we decided to do something about this and to seek for the improvement. So obviously, cybersecurity is a process, right? So the last year we were doing the things that I will discuss now. Next year or this year, this will be something completely else. So why do we even need to? What pushed us into this direction to look for improvements in this area? First, there is no perfect security measure, right? I mean, all of those measures that we implement, at some point they fail, and the worst thing is that many of them will fail silently, right? So if they fail to detect an attack, good luck looking for any kind of information later in the forensic stage, in the response stage, about what happened, right? Good example here is an signature-based AV or IDS. So these, if they fail to detect a threat, they will provide you very little information about what happened later. The alert fatigue, something that we experience very hard in Atos. We work for many customers, and we work also internally for ourselves. And this is a huge problem in SOC, right? So they deal with tons of events from tons of information security systems, and it's also a problem that we wanted to solve here. Then the time. We need a lot of time to do everything. First to understand, then to respond, to take a decision, and to implement response actions, right? The other issue that we need to address is that the manual processes that we follow that are usually followed in traditional SOCs, they are prone to human errors, right? So even if you prepare this nice work instruction that says everything, line by line, how to do something in a given system, how to open a ticket, how to block a domain, whatever. I mean, people will forget things, right? Maybe something will not work the first time, they will experience some kind of an error, they will decide to do it later, and later they will simply forget, right? So mistakes happen. Then the insider threats. So this is the completely other animal, because if we have users inside of the environment, as you know, they will usually use the level of access they already have, the tools they already have to cause us harm. And the only thing that can change or potentially will change in such a situation is basically the behavior profile of such a user. And the last one is not actually a problem that we wanted to solve. This is actually an opportunity that I mentioned at the beginning, right? So a lot of the data that we need is already available. We just lack technical capabilities to actually do something about that in an efficient manner. So what was the goal? The goal was that to basically change this legacy traditional SOC approach when we have, SIEM log, we collect logs, we have correlation rules, we have the SIEM that aggregates logs from systems, but also alerts from other security measures. And we wanted to, or we created, basically we added some things on top of that, right? So we wanted to improve detection by going into user behavior analytics to detect changes in user behavior profiles. And most of all, we also wanted to address this decision support and response issues, right? To be able to respond quickly and to avoid human errors, and preferably for those, like playbooks that we have that are solved by the analysts the same time each time given incident or event happens. We want to automate them all together, right? From the beginning to the end. So what do we need to look at to solve this? So this is the good old attack kill chain that you all already know. So on the blue team side, what we need to be able to track the attackers throughout this kill chain are alerts, right? Of course, there is more. There is threat hunting, there is forensic stuff, but on the first layer, it's alert, right? And we have a lot of different solutions that generate alerts. And what we are doing in scope of what we've done in scope of this improvement, is we added one more, right? So this will help to detect better, but it doesn't solve the issue with alert fatigue, right? And then it gets more complicated. We also need the context, right? So the insights. We need to understand who the user is. So we need to access different systems to get this information about the asset, about the user, about the entity, right? And again, multiple sources for context. Then there is a decision to be made. And again, there are multiple possible decisions. And it may be simple in one organization, but when we, as Atos, we face multiple environments, many customers, this gets more complicated because you just add next boxes into those columns. And finally, when you detected the alert, you have all the insight, you investigated, you gathered all the events, you need to take remediation steps or to respond somehow. And again, there will be multiple security measures, multiple systems where response actions are possible on. And again, there will be multiple response actions. And if you multiply this by different environments for different customers, it gets extra complicated. So this is the whole picture that we really need to look at if you want to solve this hassle. So to talk about this small little box that we added in the alerting part, so the user behavior analytics, the UBA. What we do here is we work on the source data, and the source data, what we started with is originally were basically the Active Directory or the event logs from domain controllers in the Active Directory environment and event logs from servers, right? So this was giving us the initial set of events and data that we already had in the SIEM systems for us, for our customers, that we could use to develop scenarios like that. I selected 4 here. We have much more right now, but just to give you an idea about the things that we are targeting here, right? And I will discuss 2 of them in a bit more detail in a second. So this part is good because it will give us another capabilities to detect anomalies in the behavior of an entity, right? Of the user, asset, whatever. But again, what we are doing here, we are just adding more sources of alerts. So what is crucial is this right part. In this right part, we want to be sure that we are able to aggregate all those detections, all those insights in one single place, and that we get those insights automatically for a given case for the analyst. So when the analyst actually touches the event, they can see what actually happened, right? And this is just the first example. I selected the simplest one that we had, and it is about quantities, right? So it basically aims to detect the changes in the quantity of events generated for a given user or host. And it's simple, but if you want to tackle this with a traditional SIEM system, and you want to be able to detect only anomalies for a single entity. So let's say if I generate a lot of events on Fridays, then it's fine. I don't want to be alerted about that, right? And I want to look at 90 days window. So in traditional SIEMs, to be able to focus on a single entity, learn the pattern for the single entity if you have like 100,000 users, for 90 days is very challenging. So this is where we implemented our solutions and big data analytics for that. The other one, a bit more fun, is related to host access anomaly detection. And we have basically like two sub-scenarios here. One is related to detecting let's say, abnormalities in the number of hosts given user is accessing, is logging onto remotely, or if the given user is accessing host he or she has never accessed before, right? So this is another example where we do it, and again, we are working here on 90 days windows. So very quickly to give you the idea how the proof of concept environment looked like for us when we were working on this, we had, I don't have a laser pointer, but in the left bottom corner, we have the codex for security. So this is the part that does the machine learning and the big data analytics stuff. So codex was a product of Atos, or is a product of Atos, that was used for financial data analysis. And we figured out we can use this also for security. And what it does is it's the source of this UBA alerts. And in the center, as you can see, we have the SOAR tool that has all the playbooks that we developed and all the stuff, and that is responsible for the orchestration. So what happens if we have, a common scenario of an attacker stealing credentials and performing lateral movement? Is we can get a detection, well, one of detections or multiple detections in the UBA, for instance, the one related to the access hosts anomaly. This will trigger the SOAR tool. And the SOAR tool, for that entity, for that particular user or host, it will query all the systems. It will query the SIEM, so no need to duplicate the SIEM data here. It will query our threat intelligence database, MISP in this case, the domain controller, so collect this insight about this user. If there were any incidents in the past for this user, if there were other alerts from other security systems that fit to the SIEM for the same user. So we want to know if we have the UBA detection, we want to know if we have maybe the EDR detection as well from CrowdStrike in this case, or if we have any correlation rules triggering for the same user in the same period of time for this entity. And all of that happens before the human analyst is involved, right? So once we have this 360 view ready, this is the first time we will go to SOC, to tier 1, tier 2, so they can look at that, they can investigate, they can see all the events, all the context that we have available for this user, and make a decision. And when they make a decision, then they can escalate, they can inform the customer by Power BI in this case, and they can basically click to automate or to perform all those possible response actions. So delete malicious emails if you were talking about phishing as the initial vector, lock user account, maybe contain a hosting CrowdStrike, transfer the indicators of compromised domain to MISP, so we can be sure that if we have another fire up like that, we can connect this to the case that was already investigated, right? So to summarize the last slide here, this was our way to go from this reactive security to prescriptive security. So we are able, for those cases that we defined, we are able to tell exactly what needs to be done and do it in a lot more automated way. So we can avoid human mistakes, human errors, and we can respond much faster. And most of all, when we work in this scenario, the SOC analysts, if they are relieved of performing all those searches, of performing all those manual actions, to block URLs, stuff that they do many times every week, this is really a huge relief for them, and they can be involved in other tasks like threat hunting or what have you, right? And most of all, a lot of this is based on the data that we already have, right? So we started simply with the logs, event logs from domain controller servers that we had already collected in the SIEM systems anyway. So this is just an improvement of investment in this category. Okay, sadly, it's a very quick one, 15 minutes, and I can already feel the look on me. So that's it on my side. Thank you very much. I'm not sure if I have time for questions or not.
Thank you, Łukasz.